This video is part of a series on formulae. The last video was on constructing formulae, generalising situations. This video is on the same theme, but it's generalising patterns. There'll be a pattern, and we'll introduce a letter such as N to generalise the pattern. So here's an example of consecutive odd numbers. That means one odd number following on from the other. So here, 4 terms, 3 followed by 5 followed by 7 followed by 9. They're added up. That sum on the left comes to the same as this product multiplication on the right, 4 times 6. So that's 4 terms, 4 consecutive odds. If we get 5 terms, 3, 5, 7, 9, 11 add up to the same as 5 times 7. And 6 terms, 3, 5, 7, 9, 11, 13 add up to be the same as 6 times 8. So I ask you to get the result for adding up 3, 5, 7 and so on until you get to 25. For that you'd need to know the number of terms involved. And then to write a formula for the first n terms of the sequence, that is where this becomes n terms on the left. Where it says 4 terms, 5 terms, 6 terms, it will become n terms. So, first connection to spot is when it's 4 terms, that was 4 times 6. 5 terms, 5 times 7. 6 terms, 6 times 8. That 4, 5, 6 obviously matches that 4, 5, 6. How to get the number of terms here from 3, 5, 7 up to 25? You might spot 4 ending at 9, 5 ending at 11, 6 ending in 13. I might spot if you double 4 and add 1 you get 9, double 5 and add 1 you get 11, double 6 and add 1 you get 13. We're working that backwards then. From 9 take off 1, 8 and half it, 4. 11 take off 1 and half it, 5. 13 take off 1, 12, half it, 6. So for 25 take off 1's 24 and half it's 12. There are 12 terms. So that's 12 terms, and that makes that red number 12, and this is 2 more obviously. So you get 2 more, it's 12, and 2 more is 14, it's 12 times 14. Now 3, 5, 7 up to 25, you could just actually count them up. So you don't have to spot the connection between the 9 and the 4 and the 11 and the 5 and the 13 and the 6. You could just count them up, write them out and count them. So it's 12 times 14. Spotting, to turn the red number into the blue number, you add 2, so 12 and 2 more was 14. So the reason they're asking part A is so you spot the connection between the red 4s, 5s and 6s here, and then to the blue 6, 7 and 8s, because then you generalise it, write a formula. So we're saying n terms, that's n in red, we become n over here, and this is 2 more. So n and 2 more, well 2 more than n is n plus 2, and you're multiplying them. So that was just to spot the connection with get the 12. So n and 2 more, that's 2 more than n, and they're multiplied, so they have to bracket the n plus 2 because all of it gets multiplied by n. And that's it. So it was spotting a connection in red, 4, 5, 6 and 4, 5, 6, to the blue that was 2 more. That was basically part B. In part A, the awkward bit was knowing how many terms were here, and it's just as easy to count them up as to spot any connection from the 9 to the 4, the 11 to the 5 and so on. So that's generalising a sequence, introducing n to represent any number. Here's a second case, odd numbers 1, 3, 5, 7 and so on. So 1 can be written as 1 squared minus 0 squared, 3 can be written as 2 squared minus 1 squared, 5 can be written as 3 squared minus 2 squared and so on. 1's the first odd number, 3's the second odd number, 5's the third odd number. There's 1, 2, 3 and there's 1, 2, 3. And this 0 is and 1 and 2, obviously 1 less. And that's basically the connections you're after. First, second and third odd number became 1, 2, 3, and the blue numbers is 1 less than that. 1 less than 1, 1 less than 2, 1 less than 3. So when you want the fourth one, So obviously going to be 4 squared, and this is going to be 1 less 3 squared. So that's the connections spotted, and once you spot these connections, they give you some questions to practice that, and then you generalise it for n. So for 7, that's the fourth odd number, it's 4 squared minus 3 squared. Now, the next part of the question asks to express 19 in the same way. So again, you've got to know 19, what odd number is that? So you could count them up. You could just write down 1, 3, 5, 7, 9, 11, so on, right up to 19, and just count them to see which odd number it is. Or again, if you look at the numbers in red here, and look at 3, double it and take off 1 gives you 5. 2, double it and take off 1 gives you 3. 1, double it and take off 1 gives you 1. So basically, to work backwards, 5, take off 1's 4, sorry, 5, add on 1, 6, and half it's 3. So 5, add 1, 6, half it's 3. 3, add 1's 4, half it's 2. 1, add 1's 2, and half it's 1. Add 1 and half it. 19, add 1's 20, half it's 10. That's the 10th odd number. So it becomes 10 squared minus 9 squared. Now, that's basically what's been done. Add 1 and half it. You could write them out as a wee sequence. Just write them out. 1, 3, 5, 7 up to 19. Count them up. There's 10 of them. It doesn't matter how you do it, but basically, it's 10 squared minus 9 squared. It's probably just as easy to count them up as to work out any little connection. And once you've got that, the part C is actually easier than that, because it's simply generalise it for n. The nth odd number, that's n squared, and that's 1 less than it. Here's n squared. There's 1 less than it, n minus 1. It's bracketed because it's all been squared. You've got to be able to break brackets. There's a worksheet accompanies this. If you can click the link in the description, you can get the worksheet with the answers. But they require, in a lot of cases, simplification through breaking brackets. So if you haven't broken brackets before, you need to go away and do that before you do the worksheet. N minus 1 times n minus 1, and you break up the brackets, you get n squared minus 2n plus 1. That's all subtracted, so it's kept in brackets because it's minus the n squared. Subtract this negative 2n and subtract this positive 1. The negative changes the signs in the brackets. N squared minus n squared is 0. Leaves you with 2n minus 1. So bracket breaking to simplify is required. So that's a bit trickier because it's got this bracket breaking to simplify, fully simplify this expression, so that n squared minus brackets n minus 1 all squared isn't too difficult to get. But you've got to break the brackets up to simplify. There's the results of that. So that's what we had for the whole question. Again, this part, now it's the 10th term, just counting them up is as easy as figuring out a rule. So the worksheet will have 8 questions of that type. The answers will be with them, so the answers will be on the worksheet. So click the link in the description. That's the PDF that's available. It's got the 8 questions and it's got the answers with them. You can see there's towards the end there's a very hard bracket breaking at the very last one. So particularly the last stage, the last 3 there involve squaring away brackets, in one case cubing brackets. So if you haven't done that before, you need to do that before you tackle the worksheet. Next video is on formulae again, change of subject. Hope you found this video useful. Thank you.